Assalamualaikum and hello everyone. Welcome to a new video for 6.2 equilibrium constant. In this video, we will continue to calculate Kc, Kp or the quantities of species present at equilibrium. So right now, let's look on your notes on page 8. Okay, so we're going to look at, for example, number 5. So here, for example, number 5, it mentioned that initially 3 mole of HI is placed in a 2-liter flask. At 500 K, the equilibrium mixture contains 0.6 molar I2 gas. So calculate Kp. So again, we're going to use our ice table. And then remember that for the ice table, you also have to write down your what do you call that? Your equation. So, from the question itself, it gives you that the equilibrium mixture contains 0.6 molar I2. Okay, so from here, I know that my equilibrium, the value that, the given value is actually concentration lah, molar. So, dekat sini, I'm going to write down, it is actually molar, molar, molar. Okay, write down. Okay. But then, sebenarnya dekat sini, dia bagi kata calculate Kp. Tapi kita tahu ni M. Sedangkan kalau Kp, pressure kan must be in ATM kan. So, from here, actually kita kena guna yang ni. Kp equal to Kc RT delta N. We have to relate. So, this is actually the example where we will relate back. We're going to combine our knowledge about ice table and the equation. So sebab sekarang ni the only information that we have is actually concentration kan. So cari dulu, kita kena cari kita punya Kc. Later barulah kita boleh cari kita punya Kp tu lah. Okay, so from here dekat sini, remember that for the reactant, initially memang we have our value lah. Okay, from here, okay, cuma dekat sini dia bagi tahu initially 3 mole of HI is placed in a 2-liter flask. So, here is actually mole. Dekat sini unit kita concentration. That remember for our concentration is actually now number of mole over volume, where volume must be in liter. So, dalam case ni kita punya molarity is actually 3 divided by 2 is equal to 1.5 molar. So, kita cannot use yang 3 mole ni. So, this is actually mole. We want concentration. So, letaklah dekat sini 1.5. 1.5. But the case of our product, it will be 0. Minus is actually for the reactant. Plus is actually for the product. Make sure if you have stoichiometry, include it before our X ni lah. Okay, so from here, we know that I2 is actually 0.6 molar. Okay, dekat sini, but then I want to write down my Kc dulu. So from here, we have to find out the concentration of H2, I2 and Hi. Okay, I2 dah tahu dah. So, for H2, it's actually equal sahajalah. So, I'm just gonna write it down here. So, from here, kita boleh carilah kita punya concentration of HI in equilibrium. Okay, yang ini kita tak perlu cari X atau apa sebab kita tahu straight away. X equal to 0.6. So, right now, we have find out kita punya H2 dah ada, I2 dah ada, HI pun dah ada. So, we can only substitute straight away. So, sekarang ni, we know that our Kc is equal to 4. But then, the step is not yet finished because we also have to find out our Kp. So, Kp, the formula is actually Kp equal to Kc RT delta N. Okay, remember that R is actually your gas constant, 0.08206. So, liter ATM per mole per Kelvin. So, it means that the temperature must be in Kelvin. So, as we can see here, temperature is 500 K kan? So, tak perlu tukar lah. Okay, delta N is actually mole of product minus reactant. So, kat sini, for the calculation ni, I'm just gonna write down juga apa yang kita ada. Okay, Okay, delta any mole of product. So here 1 plus 1. So maknanya, so here 1 plus 1 minus dengan number of mole of reactant. So 1 minus 1, 1 plus 1 minus 2, which is equal to 0. So next what we're going to do is actually we have to substitute the value. Okay, so that is the answer. So dia akan sama lah. You have to show the working. Walaupun kita tahu here kalau to the power of 0 it means that Kp equal to Kc kan. So sebab itulah kita dapat jawapan kita equal to 4. So here dah become equal to 1. Okay, so that's it for question 5. Yang question 5 ni dia jadi extra sikit sebab dia given kita tentang concentration, but we're going to find out Kp. So yang ni extra dia, we have to use that. Remember T must be in Kelvin. So question 5 ni as if question 6 juga. I believe you could try yourself. Okay, next is actually question 7. So for question 7, kita tengok dekat sini. At 1280 degrees Celsius, the Kc for the reaction is 1.1 exponent negative 3. Okay, yang ni yang lain sikit sebab previously kita kena cari Kc kan. Calculate Kp ke, Kc Kp ke. Sini C, sini apa lagi? P. Okay, for this case pula, dia dah bagi kamu Kc. So, here mention that if the initial concentration for Br2 are 0.063 dengan Br2 adalah 0.012, calculate the concentration of the species at equilibrium. So yang ini dia terbalik sikit sebab dia bagi Kc, kita kena cari pula dia punya concentration at equilibrium. But before that, let's write down the equation. It mentioned that the value given is concentration kan, and dia bagi kita Kc. So all the ice table ni pun must be in molar lah. So tapi dekat sini yang uniknya dia dah bagi dah initial concentration not only for our reactant, dia bagi juga pada produk. So bila dia bagi, kita use je the information given. Again yang pasal change ni, kalau reactant jadi minus, ni minus x, here plus buat produk tapi plus 2x. So equilibrium kita gabungkan saja. So this is actually dia minta dekat sini, calculate the concentration of this species at equilibrium. Okay, so macam mana nak cari? Kita dah ada Kc. So write down dulu what is our Kc. So make sure dekat sini dia Br to the power of 2 tau. Yang ini pula Br2 tapi dia to the power of 1. Okay, so macam mana kita nak cari? So kita substitute lah. Kc kita is this one. Yang ini Br to the power of 2 is actually our yang ni 2Br here. Br Br to the power of 2 is this one. And then our Br2 bromine molecular, kiranya bromine gas kita ni is this one. Okay, so sekarang ni dia jadi panjang sikit step ni, sebab itulah Miss bagi macam one whole, macam half of the page kan. Sebab step dia panjang. In this case, X ni first kita ada 2 kat sini. Lepas tu yang ini kita kena expand kan. So from here, once I solve the quadratic expression, I know that the value of x is ada 2 kan dekat sini kan. Okay, so which of the value will be used for the x itself? So kat sini kan, x ni macam mana kita nak guna? Dia jadi panjang sikit. So nak tak nak, we're going to substitute in this 2 value. Kita akan substitute kan, when x is equal to this one, what will be the concentration at equilibrium for this, and the concentration when x is equal to this value, what will be the concentration of Br2 and Br gas. So kat sini I'm just going to write it down. So we know that the concentration of Br2, so jangan lupa substitute juga untuk yang Br ni jugalah. So, sekarang ni kita baru substitute when x is equal to this value. Next is actually kita kena substitute if x is equal to this value pula. Kat sini, so which value will be used? Okay, dalam kes ni, concentration will always be a positive value. Concentration kita kalau kamu tengok lah, tak pernah jumpa pun concentration of HCl ni adalah negatif 2 molar. Dia tidak. It's always a positive value. So, bila kita tengok ni, okay, for the parent when x is equal to negative 1.1793 exponent negative 3, okay, concentration for both of the species is a positive value. Okay, so boleh lah. So, sekarang ni, when x is equal to negative 0.0149, okay, satu ni positif, it's a positive value. Tapi dekat sini, one of it is actually concentration dia is a negative value. So, yang x ni kita akan ignore. Yang ini kita akan tulislah ignore. Sebab there is no concentration negative value. Yang ini pun kita kena ignore sekali lah. Sebab maknanya kita substitutekan x is equal to negative 0.01049. So, maknanya, panjangkan step dia. From here, we know that the concentration for the BR2 is this one. And the concentration for BR is this one. So, kita concludekanlah kita punya calculation. So, this is actually the value lah. Okay, so sebab kali ni kita tengok kan, dua-dua ni negatif. So, nak tak nak sebenarnya, selagi kamu start substitute until at the end, dah cari concentration of the concentration ataupun pressure of the species at equilibrium, jangan kamu ignore lagi. Kita dah cari yang ini kan, buat sampai last kali. Dah last kali tu, contohnya kalau ada negatif 8 atm, mana ada pressure negatif kan, value dia kan. Dia selalu pressure tu positif lah value dia. So, the same goes for concentration. So, dekat sini, kita boleh tulis lah. Okay, so from here, dia panjang sikit step dia. It's quite a lot. Satu, sebab kamu nak expand macam ni lagi. Satu, kita kena try one by one. So, mana yang ada negative value tu, kita akan ignore. Tengoklah kalau pasangan ni, kalau yang ini kita ignore, maknanya this one pun kita automatically kita akan ignore juga. Okay, so, yang ini jangan risau. Misalnya dah bagi 1, 2, 3. 1, 2, 3 example kamu boleh guna. 1, 2, 3 example that you could use for exercises. Okay, so that's it for this video.